The Košak mill, or Mlin Košak, now operating its 7th generation, has been producing flour at the same location since 1767. Located in the Dolenjska region of Slovenia, or the traditional Lower Carniola, Dolenjska is known for its rich agricultural history and some of the best natural spas in Central Europe. Characterized as continental climate and suitable for field crops such as wheat, buckwheat, and corn, you will also find cooler climate fruit production, with orchards and wine growing reserved most often on the gentle rolling hillsides. Agriculture remains prevalent, while the presence of water and hydro energy has once dominated industries of the past. The main rivers are Krka and Sava, which are tributaries of the greater Danube River network. The earliest records of the Košak family mill date to 1752. Although the Košak family is certain the mill was producing flour much earlier to that date. The water turbine was installed in 1962, with a renovation of the mill and family residence on the upper floors in 1971. The current mill was built by Mr. Andrej Grudin, the director and milling expert of the Žito Bakery Company, one of the largest commercial mills and bakeries in Slovenia. The milling cycle begins when grain is transported by forklift from raw material silo storage to the front door of the mill. The grain is then carried by wheelbarrow and dumped in the grain chute on floor 1 leading to the basement. The grain will sit in bucket storage in the basement before beginning its journey from grain to flour. The interior of the mill was built using spruce, a straight grain wood commonly found in Slovenian mills, known for its lightweight and easy to work properties. The original water wheel and transmission were made from oak, harvested locally and left outside for a minimum of 5 years to dry, ensuring its longevity. The current transmission, shafts, gearing, and much of the moving machinery is made from steel. The grain is then carried by a series of bucket elevators to the top floor, where it first passes through an auger machine used to clean the grain by removing large impurities. The auger machine separates heavier debris such as rock fragments, earth, and mud.
This one carry upstairs, goes to sieve.
The grain passes through a second cleaning machine called an aspirator, which removes lighter impurities such as straw, dust, and low-density particles. The final cleaning machine is a wheat scorer, which is used to clean the surface of the grain and further remove lighter impurities before the milling can begin. This chute shows the grain being deposited after it has passed through all cleaning machines. A bucket elevator will then collect the grain and deposit it to the hopper of the roller mill. Once the grain is clean, it then passes through the first plate of iron rollers, which crack the grain and begins the separation process of endosperm, germ, and bran. Roller mills provide less friction, keeping the kernel temperature cooler, thus reducing oxidation and ensuring stronger aroma compounds and more flavor in the final product. Here, Blash is seen showing the separation of bran from the cracked kernel in the first milling cycle. After passing through the first roller mill, the material is then carried to the top floor where the refining process takes place. The top floor consists of a square plan sifter and a horizontal vibrating sieve machine, which are more commonly used when particles of flour begin to arise. The material drops back to the basement level to pass in the second roller, which contains smoother plates suitable for endosperm material. Here at the Košak mill, the master miller determines when the particles are acceptable for endosperm milling or further refining with the use of levers and chutes throughout the mill. Everything is mechanical, done by hand. Here it's the old school way. Heading upstairs to the top floor, the grist material now begins the refining process, which cycles through the milling machinery until reaching the desired consistency. The machines that do the magic here are the vibrating sieve machine and plan sifter. The sieve machine separates the bran and germ from the granular endosperm particles. These particles vibrate throughout the machine and are sorted through different sized screens, depositing the material through the chutes for further processing throughout the mill. Here you have a bucket elevator shown carrying powdery particles after the grist has passed several times through the roller mill, sieve machine, and plan sifter. This material will continue to be processed until Mr. Košak determines when the material is suitable for flour. The plan sifter is a super important piece of equipment and is used to yield powdery particles, or flour as we call it. This rotary machine sifts and sorts granular and powdery particles using multiple large surface area sieve stacks to separate. Basically, it's a giant vibrating rotary machine with many different levels of screens where the material passes through each level, becoming finer and finer before finishing as flour. The mill runs on 8 kilowatts of energy, 7 of which are powered by electricity and 1 kilowatt powered by water. To power the mill, the sluice gate is open, allowing water to flow through the turbine. The turbine converts hydro energy into mechanical energy, which is harnessed using a transmission and generator. The remaining electrical power is then turned on, while the milling machinery is powered by a combination of the two. Here, Blaž can be seen opening the sluice gate to start the initial water power, which powers the generator.
This is first thing. You use water, and then we turn on the electric motor. But it's moving really fast. Yeah, but for rollers, for milling, we still need more power. Now I just would open the electric power.
All flours are blended to reach various mineral or ash contents in the final product. The higher the type value, or T value, the more ash or mineral that's left in the mix. In Slovenia, for example, type 400 or 500 would correlate to American white bread flour, while T850 would be a lighter colored whole wheat bread flour. The higher the T value, the darker the flour, with more bran and germ in the mix. High extraction flour means greater bran and germ, darker colored, while low extraction flour would be the whitest of the white.
This is barley flour. Look, barley. It's really grainy.
The last phase of the milling process is to package the product for market. Flour is packed by hand using a flour scoop, sack chute, and scale, ensuring accurate weight. The larger quantities like 25 or kilo bags are cost-friendly for the consumer, while the smaller quantities are priced higher per weight of flour. The retail shop is open Mondays through Saturdays, where you can always find freshly milled flour and the sounds of an old-time mill. Mlin Košak also sells business to business and delivers throughout Slovenia, Croatia, and even parts of northeastern Italy. If you find yourself in Slovenia's tiny capital city of Ljubljana, make sure to visit the original sourdough bakery Pekarna 8 in Old Town, as they've been sourcing Mlin Košak flour since day one. This concludes our mini milling documentary featuring the Košak artisan mill of Dolenjska, Slovenia. We hope you enjoyed the brief milling history, technology, and perspective the Košak family shared through their family's 250-year history of artisan flour production. We encourage you to get involved with your local mill, food source, and artisan bakery. Without your continued support and enthusiasm for sustainable and nourishing food systems, these artisans and mills wouldn't exist. Lastly, we encourage you to learn more about Slovenia and the natural beauty this cultural melting pot can offer. From mountains to sea, valleys to pasture, villages to cities, Slovenia has something for everyone. Thank you.